Welcome everyone. In this video we're going to learn about factor theorem and how it can be used to find the factors of cubic polynomials or higher degree polynomials. So we have a question in here. Show that x plus 1 is a factor of this cubic polynomial 2x cubed minus 5x squared minus 4x plus 3. So, let's begin with the reminder theorem in here. If p of x, that's a polynomial of this one, is divided by x minus alpha, then the remainder is p of alpha. Okay, so that's a reminder theorem. And how can we use this one to find the factor? So we already know that. Okay, let me start with a simple example. If I'm dividing 15 by 3 and I got 5 here, 15 and then 0, 0 is the remainder. Okay, if the remainder is 0, then 3 is a factor of 15. So the same thing applies to the polynomial as well. If the remainder is 0, then this x minus alpha is a factor of the polynomial px. So that's a factor theorem. For a polynomial px, if p of alpha or the remainder is 0, then x minus alpha is a factor. Okay, this simple statement, the factor theorem, can be used to see if x plus 1 is a factor of 2x cubed minus 5x squared minus 4x plus 3 in here. Okay, let's learn a little bit more general expression before we solve this particular question. Let's learn about more general statement of factor theorem before we solve this particular problem. So we have this general statement of reminder theorem. If p of x is divided by beta x plus alpha, then R, the remainder, is p of minus alpha on beta. Okay, so the factor theorem for this statement, the corresponding factor theorem for this statement is, if this remainder is 0, then beta x plus alpha is a factor. Now let's solve this problem using the factor theorem. Prove that x plus 1 is a factor of this polynomial. Okay, let's use a simple statement. If p x minus alpha is a factor, then p of alpha, the remainder, equals 0. Okay, so comparing these two expressions, we can quite easily see that alpha equals minus 1. So to prove that x plus 1 is a factor, we need to prove that p of minus 1 equals 0. So this is what we're going to check. Okay, let's find p of minus 1. P of minus 1 equals 2 times minus 1 cube. Minus 1 cube is minus 1. Minus 5 times minus 1 square is plus 1. Minus 4 times minus 1 plus 3. So that's minus 2 minus 5 plus 4 plus 3, which equals minus 7 plus 7 equals 0. So that means this equals 0 and x plus 1 is a factor. Okay, once we found that one, so this is how we always find the first factor of a cubic polynomial using the factor theorem. And now we need to find the other factors. For that, we need to divide this polynomial by the factor we just found. And then we'll get the quotient, which will be a quadratic. And then we need to factorize that quadratic polynomial. Okay, let's run through that process. Okay, let's divide this polynomial px with x plus 1, the factor we just found. The process I'm going to use in here is the long division. You can use the equating coefficients if you want. Okay, if you don't know any of these methods, refer the videos on long division or equating coefficients. Okay, so the first step in here is to divide 2x cubed on x, which is 2x squared, and then multiply these things together. So it's a 2x cubed plus 2x squared, and then subtract, and which is minus 5 minus 2 is minus 7x squared, and this is 0, and drop down minus 4x plus 3, and repeat this process again. Divide this first term with the first term here, so which is minus 7x, and then multiply this minus 7x with the divisor, so minus 7x squared minus 7x, and subtract minus 4 minus minus 7 is 3x. This subtract to give you 0 plus 3, and finally divide 3x with x, which is 3, and multiply with the divisor 3x plus 3, and the remainder is 0 as we expected, because we already found x plus 1 is a factor by using the factor theorem. Okay. Now we can write the polynomial 2x cubed minus 5x squared minus 4x plus 3 as x plus 1 times 2x squared minus 7x plus 3. So this is of the form px equals dx qx plus rx. Rx is a remainder, which is 0 in this case. Now, to find the other linear factors, this is a quadratic polynomial that we got as the question in here. And we need to factorize this polynomial. This is not a monic polynomial. Monic polynomial is the one with the coefficient 1 in here. So we can use different approaches in factorizing this quadratic polynomial. One would be using the quadratic formula, and there are two other methods I can show you in here. Okay, so we can use any method which is more preferred by you. Okay, so to factorize 2x squared minus 7x plus 3, in one method, what you can do is you write down those terms like this, 2x squared, and then write the constant term next, and then write down this little term in here. And then now we need to find the factors of each term, the 2x squared and 3, which when we cross multiply and then adding gives minus 7x. Okay, so this involves a little bit of trial and error. Okay, so I'm just going to write 2x squared as 2x and x. That's one possibility. Let me try with that. And if it doesn't work, I need to try a different one. Okay. 2x and x, and for 3 there are different possibilities. I can try 3 times 1 or 1 times 3 or minus 1 times 3 or minus 1 times minus 3 or minus 3 times minus 1. So any such possibilities would go in here, but the purpose is when we add whatever we get in here, we should get minus 7x. So let me try with 3 and 1. So write down 3 in here, 1 here. When we cross multiply these terms, 2x times 1 is 2x and x times 3 is 3x, which when we add get 5x, not 7x. So that's not a good option. So if we pay a little bit of attention in here, so you can see that if I put minus 1 here and minus 3 here, it will work. 2x times minus 3 is minus 6x and x times 1 is minus x, which when we add gives minus 7x. So that's how we get the factors in here, and the factors of 2x squared minus 7x plus 3 is then write down those terms together, 2x minus 1 times x minus 3, and then we got x plus 1 previously using using the factor theorem. So these are the factors. There's another method to find the factors of this polynomial, so I'll show that as well, but you don't have to do both. You just stick with one method, whichever is more easy for you. Okay, so in that one, what we're going to do is write 2x squared minus 7x plus 3, and then this term, this constant coefficient of x squared is a, and coefficient of x is b, constant term is c. Okay, so a is 2, b is minus 7, and c is 3. And now you find a times c, which is 6, and b is minus 7. Now you're looking for two numbers, which when you multiply gives you 6, and when you add, you get minus 7. Again, a little bit of trial and error method, but it's a little bit more systematic way. And you can see that two such numbers are minus 1 and minus 6. Okay, so they multiply to give you 6 and add to give minus 7. So now you can rewrite this quadratic polynomial as 2x squared minus 7x plus 3 as 2x squared. You're going to split minus 7x into minus 6x and minus x, minus 6x minus x plus 3. Usually the highest term first. If it doesn't work, you need to try the other option. Okay, so now you club these two terms together and these two terms together and then factorize them. Okay, so the highest factor for this first two terms is 2x. Take that outside and then write the remaining terms. That's x minus 3. Okay, and then when you write the next, when you factorize the next terms, the purpose is to get x minus 3. Okay, so if I want that, I need to take minus 1 outside, minus 1 times x minus 3. Okay, now the factors are 2x minus 1 times x minus 3. Okay, it's the same as we got before, isn't it? Okay, so you can use this method, or even quadratic formula to further factorize the quadratic polynomial that you obtain in here. What we have done in here to factorize a cubic polynomial, we use factor theorem to find the first factor, first linear factor, and then we use the polynomial division to find the other quadratic polynomial, and we further factorize that quadratic polynomial into its linear factors. I'll encourage you to do maximum examples possible to master this topic, because this method, this factorization is really critical when you solve a cubic equation or when you're trying to find the x-intercepts of a cubic function in order to plot the cubic function, or for any higher order polynomials. Okay, so let's stop it here.